I feel bad about how this whole unit has come out. I was was coaching futsal at the end of last term, and you did a lot of this work yourselves. I haven't given you any instruction. I feel really bad about it. We've got an assessment coming up next week. Is going to start, and I thought I needed to give you a little bit more than I have been giving you. So here's a recording. Listen to it on 2 times speed if you want. You're going to do exercise 16 in the workbooks, and we're going to be talking about spread. Woo! Spread! Love spread! Yeah. Okay, so what is spread? So the spread of data is the measure of how far the numbers in data set are away from the center, right? So we can see that obviously in this data set here, it's all quite close together. This is quite a small spread, whereas over here, it is quite all spread out. It's a large spread, right? We don't usually use the full range, right? We don't usually use the number that's this here. Yeah, the distance from the beginning to the end. Why? Because there's all sorts of outliers, right? Usually all of our data is like all right here, and then we'll have one little one over here. And if we use the full spread, it'll give a distorted view of what's going on in the data. Okay, so what we usually use is the interquartile range. And we talked about this a little bit last term, and it's the upper quartile minus the lower quartile. Looking down here, which lines are our quartiles? Do you remember? This is kind of like a Dora the Explorer moment. Comment on this video that I can't hear anything that you're talking about, but you should, yeah, the Dora the Explorer. Woo! ¿Por qué no los dos? This is your upper quartile, and this is your lower quartile, right? Remember, 25% of your data is above your upper quartile, and 25% of your data is below your lower quartile, which means that 50% of your data lies in here. Okay, so this here is usually the range that we look at. Okay, uh, yeah, this is the width of the box. Now, this can be kind of hard to understand when you're just looking at these box plots. But if we think about it in terms of accuracy or shooting, it becomes a lot more obvious. Okay. So let's have a look at these targets. Imagine there's somebody out there with a rifle trying to hit these targets. Which one of these is the most skillful with a rifle? Clearly this person here, right? They've hit the target. All of their shots have gone right there in the middle. Who's the second most accurate? Well, you kind of could have either one of these two argued as the second most, right? This one here, all of the shots are really tight, really close together, whereas these are closer to the center, but more spread out, right? And then this person has no idea what's going on. They're just shooting willy-nilly, no idea, right? And this is how we should look at our box plots, okay? If we take all these marks away and we think about what the box plot that goes along with this would be, we'd have this person here has a line here, and they've got a really tight grouping right there, right? So this person right here has like a really clear understanding of what's going on. This box plot up here is going to look more like this, right? So it's still tight. We still get a really good understanding of what the data is going to show, but the median is very different from this person here. And then this person here has probably a very similar median, but their box is quite a bit wider, quite a bit larger. And then finally, you've got this person who's not sure what's going on at all, and it's really spread out. So if you think about your box plot as being kind of a target, and the spread on your upper quartile and lower quartile, or your interquartile range as being an understanding of how clear the data is, then you're going to have a better understanding of what you're looking at. Okay. So when we compare spread, we talk about whether it's large or small, and we look at the differences between two of them. So we'll talk about one being double or triple the other, right? This one here is double that one there. So this is a larger spread than this one, right? And then this one is triple the amount of that one. So we're looking at the spread compared to each other. In isolation, a spread doesn't mean very much, okay? If you just see a box plot like this, and it's got some data down here, and without being able to compare that to something else, it doesn't mean very much, okay? So we need to talk about the two different variables that you're looking at and compare them to each other. Now, when you're looking for merit, you need to use your evidence when comparing the spread. So you need actual values. You can't just have your graph sitting there, your plot sitting there. You have to actually have the values of the interquartile range and the units of measurement. For excellence, you have to explain why that's happening. Why does it look this way? Why is it shaped that way? Why is the range this large or this small? Okay. So if we look at this example here, this is a pretty good graph, right? We've got a rugby investigation. We can see that we're looking at different positions. Here we've got the backs and the forwards, and we're looking at the weight of the people in those positions. Okay, so this here is enough to show us achieved, right? We've got our box plots, we've got our data underneath, we've done well to get achieved. If we want merit though, we have to actually give the values that are there, right? So over on the left, the interquartile range for the backs has been listed, the interquartile range for the forwards has been listed, and we can see that backs are quite a bit lighter in general than the forwards, okay? In order to get excellence, we have to explain why that would be the case. So looking down the bottom, in my sample, the spread of the middle 50% of the weights of the forwards is almost twice as wide, right? And we can see that because we're looking at this and this. And the interquartile range is 7.5 and 14.5. So definitely it's twice as large. Now, why would that be? This could be because of the varied role that forwards have in rugby, meaning that some of them need to be able to run fast and some of them need bulk compared to the backs who are primarily used for speed, right? So this person has actually given a reason for why this is the case. So that's an excellence level answer when we're talking about spread. We have to talk about why there would be such a difference in the weights of those people, right? So let's have a go at here, okay? What is the spread for these two box plots? What is the spread for these two box plots? Remember, interquartile range is what we're looking at, and the interquartile range is going to be the upper quartile minus the lower quartile, right? So if we look here, we've got, what is that? What do you reckon? 39.5 maybe? 39.5. And this one here, what is that? 43.5? 43.5. If we do our maths, boop, 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 we come out with 4, right? There's a difference of 4 centimeters. For males, what have we got here? Let's say that's 37. What have we got here? 44.5 maybe? Yeah, something like that. 44.5. Do some maths. Boop, 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 boop. 7.5, right? Centimeters. So this spread here is almost double this spread here. There we go. We've done our maths. We've gotten our merit. Now we need to explain why. Why is that the case? Well, there's no title at the top of this graph, so we don't actually know what's being compared. You know, this is actually kind of a surprising graph, right? The median in height is higher than the females is higher than the median in height of males. Probably this graph isn't talking about humans, right? Humans are usually the males of our group are usually a little bit taller than the females. So this probably isn't humans. Maybe it's fish. Maybe it's kiwi. Maybe it's something else, right? So we need that information before we can say why. Okay, same thing again. What's going on in the spread? Right, we know that we're looking at species. We've got GS and NIBR. Have no idea what those things are. But again, we're comparing weight, right? So what's our interquartile ranges going to be on these two box plots? What's our interquartile ranges going to be on these two box plots? Well, we've got 2.3, maybe 2.3. You know, these, oops, 2.3. These clearly aren't quite even, right? So this maybe 2.35. This one here, 2.75, say, something like that. And then this one here, we're going to call it 3.4. Okay, and then we do some maths. What's this number minus this number? Yeah, 1.05, right? What's this number minus this number? 0 point, what is that? 4.5? Something like that, right? So these are our interquartile ranges. Okay, interquartile range. And this one here is double that one there. Okay, so our range is significantly larger in this graph. And now to get excellence, we need to talk about why we think that's the case. Why do we think those spreads are so much larger? Next bit is outliers. What are outliers? Outliers are exception to our data, right? If we have all of this data in the center and all of this here, and then you've got one point over here, you're like, what's this dude doing here? Why is he here? So they can ruin our data, but we need to make comments on them as well and explain why they exist. Well, when we look at outliers, we're looking for this data that's a long way out from the rest of the points. And in this graph, if we were to draw the curve, right, we would see a curve here, and then all of a sudden it would be over here. So we need to actually comment on it, right? If we looked around our classroom and, everybody else is, 15, 16 years old, but then you saw a 30-year-old sitting in the corner, you'd be like, what in the world is that guy doing here? And then you'd realize, oh, that's Joseph Lane, that's the teacher. So the outlier is an important part of the classroom, but tells a different story, right? I'm in the classroom for a different reason than all of y'all are there. And we need to comment on those things, and we need to say why they're there, why they exist. So looking at these outliers here, we can see that there's two data points highlighted in yellow. This is, again, our rugby investigation. Now, this one here, clearly an outlier, right? It's sticking way out off the edge, but this one here, why is this one an outlier? Why is that one an outlier? Well, it's actually falling outside our maximum and minimum here. It's actually falling outside our maximum and minimum, despite the fact that this piece of data is all cuddled up real nicely next to the rest of the grouping. It's still outside our maximum and minimum, and therefore it's considered an outlier. Yeah. So this here and this here need to be talked about. So you can see down the bottom an example of an excellence answer. In my sample, there are two unusual values who both play in the forwards position in rugby. One has a much higher than expected weight compared to the others. The other has much smaller than expected weight compared to the others at 98 kgs. However, this player is still very close to the rest of the players' weights. Now, we need to make mention of these. It would be best to tell us why we think those exist and just say, this person could have played sumo before and has come into the forward position doing well in the scrums, or this person just eats a lot of pies and therefore they're an outlier, right? And so you actually need to make mention of these things when you're working through data.